Welcome to yet another session in business statistics. We are all aware that we take business decisions based on certain probabilities, and such probabilities are called a priori probability or the marginal probability. But as we move on, we gain certain additional information about the business scenario. Now, if you get this additional information about the business scenario, why we should not use it to our advantage, or how we can use such additional information to our advantage to improve the existing probability, and such probabilities are called posterior probability or the revised probability. Okay. This concept of Bayes' theorem is a priori probability with additional information you arrive at revised probability or the posterior probability. We will see a couple of examples and understand this in a real life situation. Bayes' theorem helps us in ascertaining or improving the probability as we move on. This Monty Hall's bet problem, which will enlighten about additional information, how it is helpful in improving the probability. See, in Monty Hall's bet problem, there are 3 doors behind which a car or goat could be there, and you pay a bet money, and then he asks you to choose one of the doors. And if you get a car, you walk away with the car. Now, let us assume that you are choosing door number 1. He is not going to open the door where car is there, so let us assume that he opens the second door. Now, the moment he opens the second door, that's an additional information for you. And immediately, there are only 2 possibilities. The car could be behind this door or this door. So, you feel that it has improved to 0.5 or 50% probability that car could be here or there. By switching to the third door, you will really improve from 1/3 to 2/3. We will see by way of an enumeration. Now you have picked 1. If the car is behind door number 1, and you don't switch, you will win. Okay, right? This is about analyzing whether you want to switch or not switch. So if you switch, you will lose. Again, the very fact that you have picked up 1 and he has shown the door 2, he is not going to open the door where the car is there, so he will only show you goat. That means what? Obviously, choosing to switch will tell you that car is behind door number 3 and you win. And in case the car is behind the door 3, he is not going to show you that, and he is going to show only 2, in which case you choosing the 3 also, you win. So in the first 3 options, 2 times you win and 1 times you lose. It repeats when you start from 2 and 3. Same way you can understand. So ultimately, if you see, by switching you have 6 times there is a chance of winning. So thereby you improve the probability from 0.33 to 0.67. So this is just to enumerate how additional information helps you to assess or improve your probability or improve the accuracy of your probability. Now we will move on to Bayes' theorem, and let us understand Bayes' theorem as a generalized form. A1, A2 are mutually exclusive and collectively exhaustive events with respective probabilities P of A1, P of A2, etc. They are all marginal probabilities are known. And B is an event whose probability is not equal to 0, for which conditional probabilities are known. Like, probability of B given that A1 has occurred, probability of B given that A2 has occurred, etc. The outcome B has happened, the posterior probability that P of A ith event occurring given that B has occurred is given by probability of A ith event occurring given that B has occurred is equal to probability of B given that A ith event has occurred into probability of B divided by combined probability or the joint probability. Probability of A1 and probability of B having A1 has occurred plus probability of A2 into probability of B having A2 has occurred, so on and so forth, up to N.
Let us look at this business scenario. A purchase manager is contemplating to increase the supply quantity of supplier B. Now let us see whether it is a wise decision. Please read the problem fully. You can just pause on the video for some time and read it fully before we proceed further.
Going through the formula and applying the Bayes' theorem concept, okay, the a priori probability or the marginal probability of a defect from supplier A or supplier B is 0.65 and 0.35 respectively. Okay. Now, the additional information the purchase manager has got from the inspector is the defect percentage is 0.8 and 0.12. Now, the joint probability, that is the probability that is a supplier 1 and defective, is a joint probability of these two. This multiplied by this will get this. Similarly for supplier 2. Now, posterior probability, that is having got this additional information, the defect percentage, what is the revised probability? That is a conditional probability having found a defect, how it is from S1 and how it is from S2, and that is given by this divided by this will give you 0.553 and this divided by this give you 0.447. Now the posterior probability in case of supplier 2 has increased to 0.447 from 0.35, the marginal probability. That is the a priori probability and that is the posterior probability. Again, supplier 1, it has reduced from 0.65 to 0.553. So it is definitely good not to place additional quantity orders with supplier 2 because you will end up more defects. So it's better to stay with the supplier 1. Let us understand by way of another example. There are 3 machines M1, M2 and M3 manufactures a component with 25%, 35%, 40% totally. Then the total quantity, the share is 25%, 35%, 40%. And the respective defects are 5%, 4% and 2%. Okay, a component that is drawn out of the produced lot found to be defective. What is the probability? It has come from machine 1. Now let us apply Bayes' theorem to find out what is the revised probability or the posterior probability. The events are machine 1, machine 2 and machine 3 and their shares, okay, in terms of total product that is manufactured. And that is given by the marginal probability, okay, or 25%, 35% and 40%. So the probability of a defect could be produced by M1 is 0.25, with M2 0.35 and M3 0.4. Now you got the additional information that the defect percentages are 5%, 4% and 2% is shown here, and that is the additional information or the conditional probability. That is a defect, given that a defect is there from machine 1, given that the defect is there from machine 2, given that the defect is there machine 3. Now the joint probability is the machine and the defect both put together the joint probability. This is a probability, okay, the marginal probability multiplied by the conditional probability, 0.25 multiplied by 0.05, and that is what is this. Now, having got this, now let us understand the revised probability or the posterior probability, which is that defect found came out of machine 1 is given by 0.0125 divided by this 0.362. Like that you can find it for the other machine. Okay, so what it means to say is that with the additional information, the probability has increased from 0.25 to 0.362. So much so in case of machine 2, it has increased from 0.35 to 0.406. Clearly we can understand the marginal probabilities having got additional information about the defects have improved the probability of assessment. Okay, that is a posterior probability.
Now we have come to the end of the session. We will meet in the next session.